Okay, let's look at the sequence of control of a three-phase electrical supply system. So the size of the cable for an industrial load must cater for any future additions of the load or extension to the factory. It is usual practice to install cables of sufficient capacity with appropriate switchgear to save additional installations, expense, and outage time at a later date when extensions are projected. The location of a switchgear of a medium voltage installation is at a separate room on the premises to which only authorized persons have access and will always be kept clean and dry. The switchgear, fuse gear, and circuit breakers should have adequate breaking capacity and should be related to the maximum short circuit obtainable from the supply system. For medium-sized installations, the switchgear is in the form of a metal-clad double or triple pole, and the neutral switches with the HRC fuses capacities are up to 300 amps and can safely handle a fault current up to 25 megavolts amps at voltages up to 600 volts. Large industrial loads are handled by circuit breakers, which of course incorporate the facilities for handling large amounts of short circuit energy automatically. A typical switchgear for a large installation usually consists of a main circuit breaker, that is the MCCB, with a busbar chamber from which are fed to various sub-circuits of the installation, each having its own smaller rated circuit breakers. It's a requirement of the IEE regulations, that is 461-5 and 462-2, that all switchgears be labeled to identify their functions and the circuits they control. In addition, switches controlling emergency services such as fire alarms, firemen's lift, and sprinkler systems should be distinctively marked, e.g. by printing them red. Adequate means must also be provided for isolating the equipment to allow access for maintenance and other purposes. Where more than one phase is brought into a building, and is in the case of industrial loads, as in the case of industrial loads, special precautions must be taken to avoid the risk of shock. IE Regulations 471 insists that all live terminals between which low voltages exist should be shrouded with an insulating material or be enclosed in arced metals, e.g. a busbar chamber containing 3 phases. Single-phase distribution boards which are connected to different phases must be more than 2 meters apart from each other. The position of the distribution fuse boards or distribution circuit breakers where MCB are used is important and should be as near. The position of the distribution fuse boards or distribution circuit breaker boards where MCB are used is important and should be as near the electrical center of the load as they are intended to serve. This reduces the cost of circuit cables to the length between the supply intake position and any particular distribution board should be taken into consideration so that the volt drop doesn't exceed the permitted maximum of 2.5% of the nominal voltage of the supply. That is in IE regulations 522-8. Submain distribution in industrial premises is generally by cables, metal sheathed, embedded and armored and served, or by busbar trunking systems. For machine shop and other parts of a factory where alterations in machines layout may occur frequently, the plug-in tap-off system is recommended. Separate submains should be installed for special electrical services such as passenger and goods lifts and ventilation systems. Submains circuits should not be run within lift shafts. In domestic and commercial installation, the distribution board is at the meter position. Or the images of the wiring diagram of three-phase electrical supply system is as shown below. Thank you.